Hi and welcome to video 13 of this Unit 4 Topic 1 Loans, Investments and Annuities in General Mathematics. Today we're going to talk about calculating the interest paid. So in the previous two videos I've set up an understanding of reducing balance loans, how they work and how we can deal with them recursively. We are going to move forward into a more formulaic approach, but for now with the recursive feature we're going to talk about calculating the interest paid. So what this means is you might take a loan, let's say, just for example's sake, $10,000, and then over time you'll pay it off. There's a payment, there's a payment, there's a payment, there's a payment, there's a payment. But of course you'll be adding interest each term where it's not fully paid off. There'll be some interest to pay back the loan. So your total amount that you pay off should be more than $10,000. It will be $10,000 to pay off the principal, plus you'll be paying some interest. And this lesson is all about calculating how much interest you paid, because that's an important figure. It's really important in making correct and appropriate investments and loans that we understand how much interest we'll be paying. A really important feature of planning financially. So the interest paid will be equal to the total amount paid off, subtract the initial loan. So all you have to do is work out how much you paid off in total and then take away how much you actually borrowed initially. So the total amount that you paid off will be N times R. Remember, N is the number of time periods and R is the amount that you're paying each time period. And the initial value of the loan is A0, whatever that was at the start, which should be fairly obvious in the question. There is one little element though. Often with the last payment, you won't actually have to pay the full amount. It's very rare that that compound interest situations allow you to pay off with an exact R value at the end. So often there'll be some half amount, maybe 30% of the final amount, etc. And you've seen that in previous video examples. So you'll have to do the number of times N that you paid the full amount plus that last payment and then take away the initial amount there. And here is what it looks like in the textbook, quite similar. They take away the last payment from the initial amount first, and then they do that from N times R, or they do the formula we've just talked about. So there's a few different ways you can do it. Depends on the information you've got and how you're more comfortable doing it. So let's extend on an example, and then we'll extend on an example we did previously. Dalton loans $1,000 at a rate of 18% per annum with regular payments of $250 per year. Once the loan is complete, how much interest did he pay in total? Now it's really important here that I get a chance to talk about this 18%, a really common loan interest rate. If you get things like unsecured loans or credit card loans, etc., be really careful because you should never be paying 18% interest. So just in your life, don't ever put yourself in a situation where you're paying 18% interest. But there's me ranting again. So he borrows $1,000. If I was to set up a table, it would be start $1,000, R 1.18, that is 1 plus R over 100, and we're talking per annum and per year, so everything's yearly here. And then the end will be 1.18 times 1,000, which is 1180, and then our payment value R is $250 each time. So I'm going to do this. I'm actually going to do it in a calculator. So again, I'm just going to put in $1,000 equals, that's set it up as my answer. Then I'm going to multiply that answer by 1.18 and then subtract 250. And I'll write down each value I get because it shouldn't take too long, hopefully. So the first one is 930 equals, the second one is $847.40 equals, the third one is $749.93 equals, $634.92 equals, $499.20, or 21 actually, not that it really matters at this stage, it's an in-between stage, $339.06, $150 and 9 cents, and then our last payment is just going to complete this payment because that's less than 200 we're paying regularly now. So at this stage I'm going to assume that I'll be able to pay off the last payment then. I do have to add interest to this one more time, so I multiply it by 1.18 and it gives me $177.11. So basically I pay off $250 1, 2, 3, 4, 5, 6, 7 times, and then my last payment's 177. So my total interest paid will be equal to the total amount I paid, 7 times 250, plus an additional $177.11, and I'll subtract from that the initial loan amount. I don't know why I drew that. And so I'll do this calculation quickly. 7 times 250 plus my previous answer minus 1,000, and that gives me $927.11. Now that is a lot to pay in interest for what is essentially a 7.5-year loan, and quite a small loan amount. We're paying off a quarter of it each time, so always be wary of how much interest you're paying, and this comes about because of such a high interest rate. Then again, if you were mortgaging for a house and it's a 25-30 year loan, you'll probably find that you do end up paying off a lot on that house loan because it's such a long-term loan, even if the interest rate's low. So you just need to understand that different elements, the time you spend paying it off, the interest rate, the amount you pay off each time will affect the interest in different ways. Let's have a quick look at example 2. Now this one we've done earlier. Corey has a $5,931 credit card debt. He can afford to pay it off. We looked at a couple of options here, and we did determine that this option was the best, but we want to know how much interest did he pay in total for both options. So I'm going to shoot back up to when we did this example, which is here, and I'm going to grab all of that working and we'll just add to it. So I'll just copy that. Now I've not really set it out as well as maybe I should, so let's be wary of that. But I'll go and do the rest in purple pen, because this is our answer to the assess question. How much interest did he pay? Well, his total interest will be equal to the number of months that he paid $400. So that's 16 months he paid $400 from. I got the 616 from there. That's where I put the number of months he paid that for. And then he also paid an additional final payment of $304.73, and then we subtract the initial loan, which is $5,931. And if I do all that in my calculator, this is just for the first option, and I get 773.73. And I'll do it for the second one as well. This one should be lower, so it's pretty similar, but there was only 15 months payment. 15 times 400 plus that final payment of 308.96 minus the initial amount 5,931, and that's equal to $377.96. $377.96. And so he paid a lot less interest on the second one, actually a little bit under half the amount of interest, but also the interest rate was pretty close to half of this, and it meant because it's a lower interest rate he was paying for less time, and that's where we get that slightly under half. The time's reduced a little bit, the interest rate's almost half, so we can expect to see that. The interest rate's quite high, but this is not a huge proportion of the original loan, and the reason why that's worked out is because although it looks like it took him a while to pay, it's only 16 months, so it's less than a year and a half, so that's quite a quick paying off time period. There's more examples in your textbook, so you've got that resource. All the best.